हेलो एभ्रिबडी हामी यो लकडाउनको क्रममै छौँ अहिले पनि र कहिलेसम्म हामीले यो कोभिड-19बाट बच्नको लागि जुन सरकारले आह्वान गरेको लकडाउनलाई कन्टिन्यूमा गर्नुपर्छ गरिन्छ र कहाँसम्म पुगिन्छ भन्ने कुरा अहिलेसम्म हत्तोपत्तो छैन। तर पनि जुन कार्यक्रम भइरहेको छ सरकारी तौरबाट त्यसलाई हामीले फलो गर्दै हामी सुरक्षित भएर आफ्नै घरमा बस्नुपर्छ र यही क्रममा हाम्रो पढाइलाई जुन असर परिरहेको छ त्यसलाई चाहिँ हामी अलिकति भए पनि केही यहाँबाट फाइदा लिउँ भन्ने उद्देश्यले भाइ बहिनीहरूको सहयोगको लागि म यहाँ उपस्थित भएको छु। र आज हामी अस्ति हामीले कन्टिन्यू गर्ने क्रममा साइन्सलाई कन्टिन्यू गर्दा प्रेसरमा हामीले थ्योरिटिकल पोर्सन चाहिँ हामीले कम्प्लिट गरेको थियौँ। त्यसमा न्युमेरिकल पोर्सन पनि एकदमै इम्पोर्टेन्ट र सबै जान्नुपर्ने कुरा भएको हुनाले आज हामी त्यसलाई फलोअप गर्दैछौँ। ल त केही एक्जाम्पलहरू न्युमेरिकललाई गर्नको लागि हामी हेरौँ। Find the liquid pressure given by liquid having density 13.5 gram per centimeter cube as shown in diagram. Solution 13.5 ग्राम पर सेन्टिमिटर क्युब र यसमा यो जुन एटमोस्फेरिक प्रेसरले होल्ड गरेको त्यो लिक्विडको लेभल 76 सेन्टिमिटरसम्म छ भने पक्कै पनि यो लिक्विड चाहिँ के हुन सक्ला एकचोटि सोचौँ त सबैजनाले। यो पक्कै पनि मर्करी हो। त्यसैले मर्करीलाई हाम्रो एटमोस्फेरिक प्रेसरले जुन अर्थको एटमोस्फेरिक प्रेसर छ सर्फेसमा यो सी लेभलमा हो। सी लेभलमा हामीले यदि मर्करी ब्यारोमिटरलाई यसरी राख्ने हो भने यो ब्यारोमेट्रिक ट्युबभित्र मर्करीले 76 सेन्टिमिटरसम्म होल्ड गर्न सक्छ। त्यो कुरा चाहिँ हामीले थ्योरिटिकल उसमा पनि बुझ्नुपर्ने हुन्छ र यहाँ हामी यसैको न्युमेरिकल गर्दैछौँ जसको लागि हाइट up to which the mercury level is held which is given 76 centimeter and to solve the numericals here we have to find out the pressure. It means pressure only in SI unit, that's why we have to change this centimeter into SI unit which is meter dividing with 100 0.76 meter. Then density of mercury which is given 13.5 gram per centimeter cube, and to change it into kg per meter cube SI unit we have to multiply it by 1000. It means it becomes 13500 kg per meter cube, and acceleration due to gravity also have to be used here, and which is 9.8 average value we have to use here, meter per second square in SI system. And pressure is equal to what? We have pressure P is equal to HdG. We have already proved it, and as the formula we have to use here. And value of H is 0.76 into D 13 1500 SI system, and into G 9.8. 100,548 Pascal. Okay, after multiplication we get 100,548 Pascal, and it is the pressure given by mercury on the surface of the earth at sea level, because this is the mercury barometer, and up to 76 centimeter height the mercury level is held by the atmosphere. That's why, and it is always in sea level. It is the standard unit, the standard quantity of atmospheric pressure, which is 760 mmHg. Similarly, we can watch the second example. Find the value of unknown quantities as the following. In this figure, pressure have to be given from the piston A, and the pressure moves outward from B and C with equal pressure according to Pascal law. And according to Pascal law, two quantities have to be taken, which are force and area. And in the piston A, there are force F1 and area A1, and piston B, there is area A2 but not force. We have to find out it. And in piston C, F3 is given and A3 is not here. We have to find out it. Now, solution. According to Pascal law, we have to use the relation, but taking piston A and piston B first. For this, F1 is 50 Newton, A1 is 15 centimeter square. We have to change into SI system. That's why 15 divided by, if there is only 1 centimeter, then we have to divide by 100. And here is the square. That's why we have to divide by 100 into 100. It means 10,000 meter square. It means. Then F2 is equal to, A2 is given, which is 30 centimeter square. Same as the first, 30 divided by meter square, and here is not F2, that's why we have to find out it. We have F1 by A1 is equal to F2 by A2 is the relation of Pascal law. Or here we have to find out F2, it means F2 is equal to F1 into A2. F1 is 50 Newton into A2 is 30 divided by 10,000 by A1. A1 is 15 divided by 10,000. 10,000 cut. 15 2s are 30. It means 100 Newton. Value of F2 is 100 Newton. Similarly, again we can take piston A and piston C as well as or piston B and piston C also. We have to find out for the piston C, find the value of A3 related to piston C, and for this we can take A and C either or B and C. Taking A and C. And for this also, we have to use the relation same as the first. That's why F1 by A1 is equal to here F3 by A3. And here we have to find out A3. That's why A3 equals to F3 into A1. F3 is given, which is 200 Newton, into A1 is 15 divided by 10,000 divided by F1. F1 is, sorry, A3. F1 is 50 Newton. A3 is equal to हो जाए 60. 60 divided by 10,000 meter square, and as the previous one, to write in easiest way, we can write in decimal system as well as in centimeter system. To change into CGS system, we have to multiply it by 100 into 100 because here is square, that's why 10,000 cancel. 60 centimeter square is the area of piston C. Therefore, here in the question there are two unknown values, F2 and which is 100 Newton, and another one is A3 which is 60 centimeter square. Like this one problem can be solved using Pascal law, and this type of question will be asked using hydraulic press also, and that relation we have already proved also in the theoretical portion, and by using this relation, Pascal law, then in that problem also we can solve easily in the same way. Okay, now we are going to discuss the another question, third type. Third type of question: what portion of a block having density 800 kg per meter cube inside water, which is partially sinks into water? For this type of problem, here only one density is given, that's why you have to write density of block. We can write dB. B is block, 800 kg per meter cube, and this one block is taken into water, that's why density of water also is needed here, and which is dW, density of water, and it is in this is the SI system, that's why in SI system density of water we have to write ourselves, which is 1000 kg per meter cube, and we have to write, or we have to find out here what portion is inside water when it is taken into water. The question is this, and to solve this type of problem there are different ways. This is the mathematics, and mathematical solution can be done by using different type of methods, and here one method I am giving you, which is I think which is easier also, and for this type of problem, if this type of problem is given in different way, different point of view, but in that case also you can solve by using the same way. There will not be the confusion. That's why firstly we have to know the block which is taken into water is floating object or sinking object. Firstly we have to find out it. Obviously, according to question here is given inside water and which is partially sinks, it means it is floating. And according to the law of flotation, floating object means we have to use the law of flotation. That's why According to law of flotation, weight of water displaced is equal to weight of block, which is floated into water. Weight of water displaced. What is the formula of weight? We have to know it, very easy. Mass of displaced water into acceleration due to gravity is the formula of weight. And here also, by the same way, we have to write mass of block into acceleration due to gravity. These two can be cancelled here. And again, mass is not given in question. That's why again we have to use the formula to change into mass also. And to change it, we have to use the formula of density. Density is equal to m by v. And what is the formula of mass? Density into volume. Density of water into volume of displaced water. This one rule have to be used, this one formula. Here also, density of block into volume of block. And to find the ratio, portion means ratio. What part is inside water, we have to find out it. That's why here, this is the volume of displaced water. Volume of displaced water is volume of portion of that block inside water. That volume is displaced. And total volume of block is here. We have to take this one VV here. We have to shift in left hand side. Then if you shift this density of water in right hand side, then density of block divided by density of water. Or this one, volume of displaced water is the volume of block inside water. And this is the total volume of block. Volume of block inside water and total volume of block. Inside water and total volume of block is equal to density of block, which is 800, divided by density of water is 1000. And volume of that immersed portion, immersed part, and total volume. Ratio of these two is the part inside water. According to rule of fraction, inside water equals to 4 divided by 5. This is the answer. And if the question is asked, find the portion outside water, then what have to be done? If you want to find outside of water, part outside of water, then whole part is 1 and immersed part is 4 by 5. If you subtract these two, then you get portion outside water, which is 1 by 5. But according to question, up to here only you have to do. But this also may be asked, then you have to do up to here. Okay. If the object which is float in water is given to you, given in question, then by using law of flotation we can solve in this way. And if this type of floating object is given in different type of way, then in such ways also, or in different ways also, same formula can be used, which is weight of water displaced is equal to weight of the floating body according to law of flotation. Okay, another one also we can see here. Example 4. Example 4. An iceberg of size 60 centimeter by 30 centimeter by 40 centimeter by 20 centimeter, having density 0.9 gram per centimeter cube, is taken into water. What height will be outside water? Okay. Question just like previous, but the given condition are different here. And in such questions also, I have already told you, we have to do by the same way. And this type of question is very much important also. Length, breadth and height of the iceberg is given. That's why from the given condition we can calculate volume of iceberg. Volume of iceberg is L into B into H. L is 60 into 40 into 20 centimeter. Then 48,000 centimeter square is the volume. And volume is in, centimeter cube. Volume is size is given in CGS system as well as density also in CGS system. It means if all the quantities are in same system, then to find the height we can use CGS also, not necessary to change SI system. But if we have to find out force, pressure, like that, then in that case only we have to change into SI system. But height may be in CGS system also. Density of iceberg, which is also given, which is 0.9 gram per centimeter cube. It is in CGS. It means we have to left it. Density of water is needed because that iceberg is taken into water, which is 1 gram per centimeter cube in CGS system. And we have to find out height outside water. And I have already told you in this question, in this type of question also, iceberg, density of iceberg is lesser than density of water. That's why iceberg is also just float into water. And law of flotation we have to use here also. We have weight of iceberg is equal to weight of displaced water. Here we have to use displaced water. Displaced water equals to weight of iceberg. Or weight of displaced water, we have already done in previous question. Displaced mass into acceleration due to gravity. And here also weight means mass of iceberg into acceleration due to gravity. Both are cancelled. Mass of displaced water is not given. It means again we have to use formula. Density of water into volume of displaced water. Here also density of iceberg into volume of iceberg. And here volume of displaced water is not given. It means we have to find out it. Volume of displaced water equals to density of iceberg 0.9, volume of iceberg 48,000 divided by density of water, which is 1. That's why I have already told you volume of displaced water is volume of iceberg which is inside water. That portion which is inside water displaced the same volume of water. That's why here we can write volume of iceberg inside water, which is 0.0 43 0.0 centimeter cube. Volume of iceberg inside water is already came. And total volume of iceberg is given. And in previous question also I have already told you ratio of this volume and this volume is the portion inside water. Now portion inside water equals to volume of iceberg, volume of iceberg inside water divided by volume of iceberg. 43200 divided by 48,000. It means after calculation we get it is 9 by 10. Again, and in the question there is asked height outside water. It means to solve it we have to find out the portion outside water. Portion outside water equals to 1 minus 9 by 10 equals to 1 by 10. Therefore, this is the portion outside water. Height outside water equals to 1 by 10 into height of the iceberg is given 20 centimeter. That's why 20 centimeter we have to multiply. 2 centimeter. Okay. Total height was 20 centimeter in the given question, and according to question and after calculation we get 2 centimeter is outside of water. It means how much centimeter is inside water? 18 centimeter. 20 minus 2, or here we can multiply it. If we multiply it by 20 here, then 0 0 cancel, 9 to the 18 centimeter height is inside water and only 2 centimeter is outside water. And if the floating object is given in different ways, I have already told you, then you can use by the same way. You can solve by the same way. Now another question. Which is sinking into water. For that also we can solve. For an example, example 5. If a stone of mass 2 kg and density 2.5 gram per centimeter cube is taken into water, what will be the upthrust of water? If that type of object is taken into water, by which upthrust that water pushes the object upward? Upthrust means upward force. We have to find out it. Mass of stone is 2 kg, already in SI system. Density of stone. Here we have to find out upthrust. Upthrust is force, and to calculate force the system should be in SI system. That's why we have to change this 2.5 gram per centimeter cube into SI system into 1000. It means 2500 kg per meter cube. Another is density of water. We have to use here, which is 1000 in SI system kg per meter cube, and upthrust is equal to what? This one stone is means density of stone is here 2500 kg per meter cube, and density of water is 1000 kg per meter cube. And by comparing these two densities, we can understand stone sinks in water. It means it is the sinking object. I have already told you, for the floating object we have to take law of flotation. Weight of water displaced is equal to weight of body. But here it is the sinking. It means weight is not equal. And what is equal there? Density. Density of, we have, no density, volume. What portion is portion of the objects? In previous question also we used that portion which is inside water is the is equal to the weight of water displaced. But here is whole stone sinks into water. It means volume of stone is equal to volume of displaced water. Okay, whole stone is sinking into water. It means it displaces the equal volume of water also. That's why volume we have to take. Volume of displaced water is equal to volume of stone. Same way it is also. And here we have to use the formula of volume. D is equal to m by v again, and v is equal to m by t. Mass of displaced water by volume of, density of water is equal to mass of stone by density of stone. Or we have to find out mass of displaced water here. Mass of displaced water is equal to mass of stone 2 kg, density of water 1000 divided by density of stone 2.5. Therefore, after calculation, mass of displaced water equals to 800 kg. 800 kg, 2 kg. Now, again, this is the mass of displaced water, not upthrust. We have to find out upthrust. And according to Archimedes law, here we have to use the Archimedes law also. Upthrust is equal to weight of displaced water. In theoretical portion, we have already learned it. Weight of displaced water is equal to, here is mass of displaced water. It means mass of displaced water into acceleration due to gravity is the weight. And mass of displaced water is 800 into, here 2.5 is in the, cannot be used. SI system 2500 have to be used. It means after division then we get 0.8 kg. 0.8 into 9.8. 7.64 Newton.
84.
Oh, 7.84, 7.84 Newton. It is the upthrust. Like this, if the body which sinks into water is given, then in this way we have to do it. Or in numericals related to pressure, again other type of simplest form of questions also will be there, and some of the hints I am giving you. Listen here. If weight of the object in air is given, which is 20 Newton, and inside water is given, same object which is inside water, and its weight is given 15 Newton, then in this example we can find different type of quantities like upthrust, or firstly weight of water displaced. Weight of water displaced by the body. Weight of water displaced is weight in air minus weight in water. 20 Newton minus 15 Newton. And after subtraction we get weight of water displaced, which is 5 Newton. And according to Archimedes law, upthrust is equal to weight of displaced water, and which is 5 Newton. It means upthrust also can be calculated here, and weight of water displaced also can be calculated. And if it is not given, weight of displaced water 5 Newton is given, then again we can find the weight of the body inside water, which is by subtraction 20 minus 5 is 15 Newton, and this one you have already done in verification of Archimedes law. This type of questions also will be asked. Another, if any kinds of rectangular or any form that may be cylindrical also, which is given into water and different height is given, h1 and h2 given, then in this case also we can find out the resultant pressure, resultant of thrust, etc., which you have already learned. Resultant pressure is equal to dg h2 minus h1, and resultant of thrust is a dg h2 minus h1. This formula have to be used, which is already discussed in theoretical portion also, and in such type means this type of questions also will be asked, and only formula is necessary. Okay, thank you very much. Today we discussed the different type of numericals which may be asked in the topic pressure, and like this you can do very well. Thank you very much, and stay at your home, be safe. Thank you.